Monotonicity means increasing or decreasing behavior. First, let's talk about strictly increasing. Strictly means it can never fall, or it can never remain stagnant also. Something like this. Forget about falling. It is not even stagnating or taking rest for a moment. It never stagnates. Stagnates means constant. Why? It doesn't happen. If I remove the word strictly from strictly increasing, then it means something like this. Let me drag it down. In case of increasing, taking rest is allowed. It can stagnate. That stagnation is allowed. But fall is not allowed. If a function is increasing, it means it cannot fall. Right? So whether it is increasing or strictly increasing, it can never fall. In case of increasing, it can stagnate, it can take rest. And in case of strictly increasing, it can't even do that. It will have to run and run and run only. Now, any questions about these definitions? If you have any questions, then let me know. So let's give these definitions some mathematical look. This is what I meant was mathematical look. If x2 is greater than x1 and f of x2 is greater than f of x1, then we say that the function is strictly increasing. In the definition, there is no mention of differentiation. That you have to understand very well. In the definition, there is no mention of differentiation. In case of increasing, if x2 is more than x1, then f of x2 can't be smaller than f of x1. It can't be smaller than that. It means it can be greater or it can be equal to that. Now suppose the function is differentiable. You know that differentiation means slope of the tangent. Slope of the tangent. And function is differentiable if function is rising up and up and up. It clearly means that the tangent will go like this, making more and more and more angle with the x-axis. Tangent will have a tendency to become more vertical. If function rises, tangent will have a tendency to become more vertical. Right? That will happen whenever function tries to rise. Tangent has a tendency to become more vertical. And if function is rising, the tangent will make acute angle with the x-axis. Acute angle with the x-axis if the function is rising. Look at it this way. When a function falls, then what happens? Imagine some tangent at any point of your liking. In case of fall, tangent makes an obtuse angle with the x-axis. And if it is acute angle, then tan theta must be greater than 0. But tan theta is dy by dx. That means dy by dx is greater than 0. Or f dash x is greater than 0. This is a geometrical visualization approach that f dash x is greater than 0. You can do it by this approach also, definition approach. F dash x at a point is given by f of x plus h minus f of x divided by h, limit h tending to 0. And h is positive. So if you are going to the right side of x, x plus h, then from the definition, if x2 is bigger than x1, f of x2 is bigger than f of x1. Right? So who is bigger, f of x plus h or f of x? Correct. And that means f of x plus h minus f of x is positive. H is always positive. Positive upon positive is going to be a positive answer. So f dash x is positive. So that's the definition approach, and graphical approach also I try to explain. If it is allowed that the function can stagnate. Stagnation means what? Stagnation means tangent is parallel to the x-axis. And if tangent is parallel to the x-axis, then the slope is 0. So for those points where it is flat, f dash x will be equal to 0. But for those points where it is not flat, f dash x will be greater than 0. So the end result is that f dash x would be either greater than or equal to 0 for just increasing. Now the problem is that the use of f dash is so much that as time goes by, you tend to forget the original definition. Every problem you blindly start applying f dash x. And that's where you can get trapped. Some questions are designed to trap you that way. So always remember that the basic definition has nothing to do with differentiation. Basic definition is x2 is bigger than x1, then what happens to fx2, what happens to fx1. No mention anywhere of differentiation in that. So if the function is not differentiable at several points, then in that case the graph can be used. You can see how it is and you can analyze its behavior, but you can't blindly differentiate in those cases. Now when we say strictly increasing or just increasing, sometimes it happens that in some part function is increasing. In some part, there's a rise, there's a fall, both are there. So in such cases we would use the interval. In this interval the function is increasing, or in this interval the function is strictly increasing. But if we say generally speaking function is always increasing or function is always strictly increasing, then it means we are referring to the domain of the function. In the domain of the function it is strictly increasing, or in the domain of the function it is just increasing. Strictly decreasing. The poor fellow is falling and falling and falling forever. Forever. Well, here in this, even stagnation is not allowed. That's the meaning of strictly. Stagnation not allowed. It must fall. Right, so height is shrinking. Height is shrinking. If you remove the word strictly, then it can take rest, but then it must fall after taking rest. Right? So stagnation is allowed, not just once, but many times it's allowed. You can have like this also. Then it can continue to fall. Several stagnations may be allowed. So here the equal to sign is permissible. Now, talking about differentiable situations, just like we discussed in case of strictly increasing or just increasing, f dash x will follow the opposite behavior. The angle must be obtuse. If you construct tangent, so tan of obtuse angle, somewhere between 90 to 180 degree, that would be negative, right? So f dash x is negative. That's one way to think, geometrical way. Other way is to look at the just definition, derivative the definition. And using that you would have limit h tending to 0, f of x plus h minus f of x divided by h. So if you go to the right side, x plus h is more than x plus h is more than x, and f of x plus h would be smaller. So you get negative in the numerator, h is always positive, negative upon positive is negative, so you get negative answer. In case of just decreasing, stagnation would mean at those points the slope of the tangent is 0, so 0 becomes permissible in that case. So you have f dash x less than or equal to 0. Again, derivative is not part of the definition. Just as we said that there could be some interval, that rule works here also. Function does not have to fall at every single point of its domain. It can fall sometimes, it can rise sometimes. When that happens, we can talk about interval. That in this interval it is falling, or there may be several intervals. Look at sine function, for example. Rises, falls, rises, falls, rises, falls, rises, falls. It happens all the time, repeatedly. So in those cases, we can talk about interval. Interval or intervals. There is a private message. If it is initially stationary and then it falls, then will it be decreasing like this case? Initially stationary and then it falls like this. The answer is yes, because the definition says that as long as if x2 is more than x1 and f of x2 is less than or equal to f of x1, it will be called decreasing. So if I take 2 points here, I am discussing from here to here, right? I take 2 points here and clearly x2 is more than x1 and f of x2 is equal to f of x1. That satisfies this definition. So yes. Any other question if you have, then let me know. Let's take problems now. Find the interval in which this function is increasing. Okay, there's no strictly here. And as I said, when you solve problems, most of the times you will be using differentiation. So somehow it becomes a habit, and then somebody is able to trap you with the basic definition. Look at this problem, for example. It's a polynomial function. Polynomial function is always differentiable. So you are going to do it like this. F dash x is greater than equal to 0. That means 6x squared plus 6x minus 12 is greater than equal to 0. That's very easy to handle. That you can handle using the wavy curve. So can you proceed on your own and see from where to where or whatever way you can get x. Whatever way you can get x. From some point to some point or something else. Check that minus 2, will it be included or excluded? Check that 1 also, included or excluded. Yes, then it's correct. Okay, now if anybody would like this to be discussed further on the board, then raise your hand. Okay, if you have any specific question, then let me know. If you don't ask anything, I will move on. Well, then I move on. Now, by the way, I think I will just show you this graph so you can see what this thing means. I put that on the whiteboard also. So, point 1, or should I ask you this? Can you tell me where do you think point 1 is located? You can use the pointer if you like. Where is point 1 located? 1 to infinity, it is increasing. 1 to infinity, it is increasing. So can you spot where this point 1 is located? That's very good. Yes, I can see that. So that's exactly where 1 is. And where is minus 2? Yes, I can see that. No, that one is correct. This one is correct. This is minus 2. So rising, 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 rising and rising and rising. Find the interval in which this function is strictly increasing or strictly decreasing, both. Alright. This is a polynomial function. You can differentiate it. If you have any questions, let me know. If you would like this to be discussed on the board, raise your hand. Okay. 3x squared minus 6x minus 9. Positive number would not affect the sign scheme. That means you can focus on x square minus 2x minus 3. So x minus 3x plus 1. Number line minus 1, 3. I think rest you can understand on your own. Answer is pretty clear from this. When is it positive, when it is negative. Let's increase the difficulty level a little bit more. Try this. B is the correct answer, but there is a little catch in this problem. When you solve, you don't get you don't get this. So what full answer do you get when you solve this problem? What is the full answer? Well, if you got sin x is greater than equal to cos x, then why not d for delta? And why not c also? Looks like there is some problem with that. Sin x is greater than equal to cos x. First of all, this is a trigonometric function. It will be differentiable. So, can you tell me what you are getting for f dash x? F dash x. Second answer is looking simple. If you are getting the first one, then see if you can simplify it to sin 2x cos 2x. Okay. Fine. So that means we can use 2 sin theta cos theta formula, which is this, sin 4x. Now yes, but then sin 4x is greater than 0 means if sin theta is greater than 0, then it means theta is from 0 to pi. And that means when you divide by 4, then it is, yes, that's okay. So it will be this. Everywhere this. 0 to pi by 4. That's what, let's check again. Are you sure your working is correct? negative sign. Okay. So that will change the picture. That means sine 4x is less than equal to 0. And that means this region. I can write negative values, but looking at the options, I am writing positive values. So this region I am writing as pi to 2 pi. Then dividing by 4, this is what we get. I already told you the answer. Correct answer is B. Now the question is, what makes it B? Because we are getting this pi by 4 to pi by 2, pi by 4 to pi by 2. Yes. Any answer to that? If we are getting pi by 4 to pi by 2, what makes B correct? Right, exactly. So if pi by 4 to pi by 2 is correct, then any part of it also will be correct, isn't it? If we say that some function is increasing in this region, this whole region, then obviously in this small region it will be increasing. If it is increasing in a big region, isn't it? So that was a little thing in this problem. It came in 99, this problem. Yes. Well, look at the quadrants. When is sign negative? Sign is negative when? Third, fourth quadrant. Third and fourth quadrants means what? 180 degree to 360 degree. I am leaving you without the answer to this. This is your assignment problem.